Pro-Vice-Chancellor, Mrs. Idreos, colleagues, friends, thank you for coming to my inaugural lecture, for making this a wonderful start to my tenure of the Andreas Idreos Chair. I should say a few words about Andreas Idreos first. He was a medical professional, a senior officer in the World Health Organization, and he took a global view of what would make for human flourishing. He became convinced that understanding between different cultures would be furthered by greater attention to the interaction between two great universals, science and religion. And one of his contributions to furthering that aim was to endow the chair that holds his name. I'm very humbled to have been appointed to play my own part in working towards his vision of increased unity between the peoples of the world. So I do want to pay tribute to that vision, an aim, if you like, before I get stuck in an academic thicket of my own choosing. Well, here is what I plan to say. First, I'll say something of my own perspective on science and religion, why me for this job, and second and third, what it says on the tin, quantum fundamentalism and theological liberty. First of all, then, why me? Well, my thoughts when I was putting this together returned to the inaugural lecture I gave for my previous role at New College in the University of Edinburgh as Professor of Natural Science and Theology there. I gave that lecture in 2019, and I spent my time speaking about the work of my three illustrious predecessors and how I would take their objectives further. And here they are in the college history on a plate delightfully entitled Professors of Chairs Now Extinct. Now, ironically, they were all biologists who were working on evolution and its theological implications. And they were doing so over a century ago. So since the chair went into abeyance between them and me for, well, about a century, it was actually pretty straightforward to demonstrate that I would be bringing something new. Unfortunately, not so with my new job. I can't possibly claim to be resurrecting something that was extinct. The Andreas Idreos Chair has been going strong throughout the 21st century, and I have three extremely illustrious predecessors, all of whom are still alive and still active. All three have made sizable contributions to the field of science and religion, which still stand. If I were to attempt to review their work, we'd be here all night. So let me just summarize it in a single sweep by saying that they've all been instrumental in developing what has become the consensus in the field over the last, say, 10 to 20 years. Namely, that the old dualism between science versus religion is unsustainable, even if that dualism still lingers on in modern society. So popular culture may still maintain that science and religion are incompatible, at loggerheads, but the truth of the matter is that both sets of enterprise have evolved alongside each other in really very subtle and complex ways, and their relationship is similarly nuanced. For sure, there has been conflict between some scientific theories and some religious beliefs down the ages, and there still are some today. Of course, we can all think of the creation-evolution debate. But there are many areas where there's little direct engagement, and there are other areas of very positive interaction. And my three predecessors in the chair have all been instrumental, like I said, in contributing to this very rich story of engagement between the sciences and religious beliefs. And I see no sign that we'll run out of questions anytime soon. So I'm sure the Andreas Idreos Chair will be going for another century. What am I going to do in it? Will I bring anything new? Well, I certainly hope so. For one thing, I'm the first physicist to hold the chair, and although I spend much of my time mixing with theologians, philosophers and historians, and I have also trained as a theologian myself, it's physics and its hinterland which continues to grab my attention. Now, I must admit that I'm not very active in mainstream physics anymore, but thanks to some long-suffering collaborators, I am able to keep my hand in from time to time in the lab and to help with the occasional publication. At any rate, I describe myself on the faculty website as a physicist working in a theological environment. I know that sounds a little pretentious, but it seems to capture my approach to science and religion, namely a concern with what drives working scientists as human beings with their own beliefs and convictions about science and our human world. Now, we all know that science changes the world. But what, in fundamental terms, and by that I mean in terms of human aspirations and convictions about what is most real in our world, what is it that drives the world of science? Why does science work? Well, the working sciences can't answer these questions. They need philosophers and theologians. That's what the science and religion field does, I would say. But there is a great deal more that the science and religion field could do, I suggest, to help working scientists grasp the significance of their daily work, to examine their working assumptions and prejudices, and to analyse their scientific hunches, some of which, I've discovered, are implicitly theological. Well, how should science and religion scholars, such as theologians, go about helping the scientists? It's not straightforward, I'm afraid. There are professional barriers to overcome. And I said earlier that there are areas of positive interaction between the sciences and religions, areas where there's lots of traffic, but it's fair to say that the traffic is almost entirely one way, from science to theology. Now, it wasn't ever thus. Once upon a time, there was a conversation both ways. And I'm thinking of people in the history of science, such as Galileo, Isaac Newton, Robert Boyle. These people were not shy of analysing and justifying their scientific work on theological grounds. But not so today. The traffic is one way. Now, there are good reasons for that. Scientists are generally unable to engage with theology in their professional work, even if they have deeply held religious convictions of their own. Theologians, on the other hand, can work freely with scientific ideas, and they tend to do so with great enthusiasm in certain areas, especially if those areas concern origins, like the origin of the universe or the origin of humans, or if they're about the sciences of the human mind. Again, that really is no surprise. The natural sciences can't, by definition, consider supernatural causes, while theologians are fully able to engage with reality on every level. The traffic is therefore largely one way in our modern age. But, and this is my personal observation, all of this means that the science and religion field hasn't done much to examine the contemporary scientific landscape beyond those relatively small numbers of areas about origins and the mind. And neither has the science and religion field done much to help working scientists understand the human dimensions of what they do, their intuitions, prejudices, and hunches, some of which, as I said, are implicitly theological. Well, I will start to explore an example of such a potential hunch with you here today: quantum fundamentalism. It's widespread in modern physics. Despite its ominous title, I'll argue that science and religion, which hasn't addressed quantum fundamentalism yet as a worldview, is actually in a unique position to be able to critique and inform it. And I'll suggest towards the end that a belief in quantum fundamentalism can be enriched by adopting a spirit of theological liberty. Now, one last thank you to some people who are here before I really get going. I should acknowledge that my thinking in this area has greatly benefited from the generosity of the Issachar Fund, who gave me a grant a few years ago to begin looking at the ways that quantum physics and theology interact. That project has been pivotal in the way that my research has evolved, and it's my hope that this area will flourish in Oxford, because the staff interests in the science and religion group here are uniquely aligned. And I'll just show you the main people I'm working with at the moment. Our research group, I think, has the potential to make a highly original contribution to this perplexing subject of what quantum mechanics means to human beings, not just scientists. So I just want to acknowledge these three people, and of course not forgetting there are others as well, but these three in particular, Dr. Emily Qureshi-Hurst, Dr. Pete Jordan, and Dr. Sean Henson. So, what is quantum fundamentalism, and why might theology take an interest? I'm sure you're thinking that theology has enough fundamentalisms to be going on with, doesn't need another. Well, perhaps, but please humour me. Quantum fundamentalism is the belief that quantum mechanics captures what is most fundamental in our physical world, even though we might be blissfully unaware of this in our daily lives. And I'll give you a more watertight definition in a moment. But first of all, where does this belief come from? Why would anyone want to believe that quantum mechanics is ubiquitous if we don't see it? Well, we do see it. First of all, let me say a little bit about quantum mechanics, what it is. It's a theoretical framework, it's highly mathematical. It was originally developed about a century ago to predict what we might see when we make observations on light and on matter at the atomic and subatomic level. And it's important to note that it's a theory of measurement, not necessarily a theory of reality in itself. When we try to infer from quantum mechanics what's really there before we make the measurement, the theory tells us strange things. And I'm sure you've all heard of Schrödinger's cat, the infamous thought experiment where the cat is both alive and dead at the same time until we open the box and look inside. Well, the philosophical disputes about what's really the case there before we open the box have been ongoing for a century now and show no signs of abating or being resolved. I will mention those disputes later, but my subject for now is really the amazing success of quantum mechanics at describing natural phenomena on all kinds of levels. And we now think that quantum mechanics works for matter not just at the atomic and subatomic levels, but all the way up. In fact, it's no great understatement to say that the quantum framework of theories is the most successful collection of theories in the natural sciences. Quite a grand claim, I know, but this collection of theories has transformed our view of molecular, atomic, subatomic matter. It forms a basic context to many scientific areas, from particle physics through condensed matter physics, chemistry, materials and earth science, to molecular biology and many other natural sciences. On larger scales, quantum physics explains why stars shine and how stars make the atoms that make people and planets. On still larger scales, cosmologists make use of quantum mechanics to explain the Big Bang and the distribution of galaxies in space. Many modern technological innovations are totally reliant on quantum science. We probably all have an example of this in our pocket. I'm thinking of a phone. So the entire electronics and telecommunications industries are reliant on quantum mechanics. And it underpins what is probably the greatest of all scientific achievements, the periodic table of elements. Now, the shape of the periodic table was defined well before the quantum revolution by Mendeleev in 1869, but it was the realization that atoms have an internal electronic structure described by quantum mechanics that really provided an explanation for this table, why the chemical elements fall into these rows and periods, and why they have many of the properties they do. But here is my personal favourite of why quantum mechanics is ubiquitous. This is from just 2 weeks ago. Do you remember the Northern Lights late on Friday the 10th of May? I don't. I didn't see them. I was fast asleep in Summertown. But my children, who were wide awake and in Scotland, were messaging me frantically saying, "Dad, you have got to see this." So this is my oldest and youngest on the beach near our house on the edge of the Firth of Forth. This is Ben and Susanna. And this is quantum mechanics at its most wonderful. And I'm not just talking about the Northern Lights. We humans are quantum mechanical to our core and all the way up, or at least if quantum fundamentalism is to be believed. Despite countless tests, quantum mechanics has always proved to be correct, and it provides the basis for some of the most precise predictions in the whole of science. And I'm going to give you one very celebrated example here. This is the anomalous magnetic moment of the electron. Just look at that row of numbers there. The calculations match the experiment to 11 decimal places, which is absolutely astonishing. And it's no wonder that physicists widely assume that physical reality is altogether quantum when we get down to brass tacks. So here, for instance, is how one of the standard textbooks on quantum mechanics begins. In the present state of scientific knowledge, quantum mechanics plays a fundamental role in the description and understanding of natural phenomena. In fact, phenomena that occur on a very small atomic or subatomic scale cannot be explained outside the framework of quantum physics. Actually, there are many phenomena that reveal on a macroscopic scale the quantum behavior of nature. It's in this sense that it can be said that quantum mechanics is the basis of our present understanding of all natural phenomena, including those traditionally treated in chemistry, biology, etc. So quantum mechanics is the basis of our present understanding of all natural phenomena, they claim. Now, in case you're thinking to yourself, surely classical physics was quite useful. Perhaps it takes over at some point, especially on our human level of pets and people, cats and dogs. Here is the great champion of condensed matter physics. That's the physics of things on many length scales, from the microscopic to the macroscopic. Phil Anderson, he wrote, "For 75 years during the 20th century, physicists, perhaps overwhelmed by the prestige of the authors of the Copenhagen interpretation, have adhered to the idea that there is some mysterious scale at which the quantum world changes into the classical. But we are quantum all the way up. There is absolutely no experimental evidence for such a scale. We are quantum all the way up. Classical physics, successful as it has been, is largely an approximation, we suspect then, to some kind of deeper, more profound description of nature on all length scales, which must be quantum mechanical." Now, you're probably aware that physicists aren't sure how to combine quantum mechanics with that other great theoretical success story of modern times, and that's general relativity. But we do expect that sometime, sooner or later, a solution will be found, and that it will be thoroughly quantum in both style and content. And that is a widespread hope in modern physics, and you can find versions of it throughout the popular science literature. So quantum fundamentalism is not controversial in mainstream physics. But I have to say, I'm a condensed matter physicist, some of us do wonder whether quantum mechanics will ever be able to replace our reliance on thermodynamics. Well, that is an open and rather technical question, and I won't go into it here, but I have to admit that condensed matter physics would be completely unintelligible without quantum mechanics. So in that sense, I guess I am as much of a quantum fundamentalist as the next person. Strangely, though, this terminology of quantum fundamentalism has only started catching on quite recently. And that mainly in the quantum foundations field. That's the field which specialises in the deep philosophical questions that arise from the quantum world. And this is probably why you probably haven't come across the term before, even if you work in physics and are perhaps beginning to think to yourself, hold on, I think I might be a quantum fundamentalist. It is an amazingly useful term for capturing a worldview, and that's where theology comes in. I will get there, but first I promised you a watertight definition, and here it is from philosopher of science Henrik Zinkernagel. He says, Quantum fundamentalism. Everything in the universe, if not the universe as a whole, is fundamentally of a quantum nature and ultimately describable in quantum mechanical terms. So everything in the universe is quantum in its being, and ultimately, that is, in principle, everything can be described in such terms. Such is quantum fundamentalism. The quantum is here to stay. But notice that this definition isn't entirely watertight. We need to examine the word fundamentally, because it's doing actually most of the work in this definition. Well, let's turn to philosophy of physics, because there's a healthy dispute about fundamentality there. Now, one rather old-fashioned view, which is still widespread in physics today, but has become unfashionable in philosophy, takes the physical world to be effectively stratified into lots of different levels described by the different sciences. And the most fundamental level on this view is the level which describes the tiniest possible things. So they are the subatomic quantum particles like the various quarks and the Higgs boson. So that's the basement on which the rest of nature is built. Those particles make up the matter of which every entity in the universe is composed, we believe. Their behaviour underpins every other level, we assume. Now, this is a common form of quantum fundamentalism. You probably know it by the better-known name of reductionism. So, for instance, this is how one very well-known particle physicist defines fundamental, Sabine Hossenfelder. She says, "A fundamental property or object cannot be derived from or reduced to anything else. The only fundamental theories we currently know of, the currently deepest level, are the standard model of particle physics and Einstein's general relativity, which describes gravitation." And she goes on to say, in the same passage, "The rest of physics, together with chemistry, biology, sociology, and so on, all the way up the hierarchy, all of it emerges from those fundamental laws of particle physics and gravitation." So that's a pretty full-blooded version of reductionism. But not all physicists are committed to reductionism to that degree, especially those of us who work on a much higher level than the subatomic particles, such as in my own area of condensed matter physics. So I, and many other people like me, take a more horizontal, or at least less stratified view of the sciences, and we still find that the quantum framework is just as effective. So I say that quantum fundamentalism is not the same as reductionism. We don't need to maintain that all of science boils down to the behaviour of subatomic particles just to believe in the reality and ubiquity of quantum phenomena. Well, philosophers of science have also moved away from reductionism. Here is Alyssa Ney. She has proposed what I find to be a helpful alternative. She explains fundamentality by looking at the ability of some scientific theories to reach far across the sciences, to influence and underpin many other theories. So the fundamental term refers to what she calls, and I put it on the slide, the explanatory maximality of a theory. I'll explain that. So a theory is fundamental if it's a common source of causal and constitutive explanations that possess the greatest, that is, the maximal, degree of scope, accuracy, and precision of all theories that have so far been formulated. In other words, what she's suggesting is that a fundamental theory simply reaches much further than others into more areas of science. And such a theory also works to unify other scientific theories by lending them its own concepts. It's possible that such a theory may not yet be complete, nor perfect, but if it's maximally far-reaching, then it's fundamental. Now, Ney doesn't identify any particular theories in this way, but I would say it's fair to conclude that the quantum framework qualifies pretty strongly on these grounds as a fundamental body of theory, because its concepts and explanations are ubiquitous across the sciences. No other theoretical framework is as far-reaching nor as adaptable, I would believe. And no other theoretical framework is as able to unite the patchwork landscape of sciences quite so effectively either. So remember Dr. Idreos' vision of the unity of peoples. Well, quantum fundamentalism may not unify nations, or at least not yet, but it does provide a starting point for a unified concept of nature, which, incidentally, has been a long-standing holy grail of the science and religion field. So it's got quite a few things going for it, quantum fundamentalism. I do at least want to commend quantum fundamentalism to you if you're not yet convinced, but I have to say there are some very, very serious downsides if you're going to be a quantum fundamentalist. So here is the cosmologist Lee Smolin on the matter. Wrong direction. Quantum mechanics has been the core of our understanding of nature for 9 decades. It is ubiquitous, but it is also deeply mysterious. Little of modern science would make sense without it, but experts have a hard time agreeing what it asserts about nature. Quantum fundamentalism can claim an impressive degree of empirical evidence in its favour then, but it struggles to provide a clear guide to reality. The basic problem is that quantum mechanics doesn't tell us clearly this is what reality is. It tells us instead what we should expect when we perform measurements. But if we want to know how things really are, we need to apply a metaphysical interpretation to the physics. But as you may well know, there's a variety of such interpretations, and to boot, they are largely incompatible with each other. Presumably one of them is right, but we don't know which one, nor how to tell. I'm sure you will have heard of the Copenhagen interpretation. I mentioned it myself a few minutes ago. That avoids making definitive pronouncements about what the quantum world looks like when we're not looking, making measurements. You've probably also heard of the many worlds interpretation, which says that there are many versions of reality, many versions of you coexisting. The cat is alive in one world, dead in another. But there are still other interpretations. All of them are challenging, if not outlandish. They raise difficult questions for human beings about what we take for granted in our everyday experience, such as distinctions like cause and effect or subject and object. These are serious problems for quantum fundamentalism, and I don't think they should be underestimated. The science has bound us to a set of seemingly absurd scenarios and abandoned us there. The science has given us freedom to choose between the interpretations, but no liberty to make an informed decision. To put it bluntly, quantum fundamentalism may claim massive scientific support, but if it can't help us to make human sense of the science, then what earthly good is it as a worldview? Well, this is where my own contribution starts to appear, because I am firmly convinced that the humanities subjects can help. Here is a question. What might quantum fundamentalism become for human being and human flourishing when it's seen through a humane perspective, illuminated by subjects like the creative arts or literature or even theology and ethics? Well, this is the wider aim of our project here in Oxford, what we're beginning to call the quantum humanities. And among those perspectives, theology is particularly far-sighted, which is why I want to speak of theological liberty. There's one obvious way that theology can help quantum fundamentalism. If there are many competing quantum interpretations of reality, and they're all empirically equivalent, then the only way to adjudicate between them is to bring our human suspicions and convictions about what lies beyond science to bear. So theology represents a pretty privileged vantage point, a liberty which is inaccessible to science. But theology can shed still more light. Notice that when I was trying to describe quantum fundamentalism earlier, I was forced into using words like aspire, hope, suspicion, hunch, conviction. Quantum fundamentalism, for all its scientific support, is in the same conceptual space as theology when it draws conclusions about the world. Few physicists commit to one or other of the quantum interpretations, and that's partly because we have the same misgivings as everyone else, but we do firmly believe in the reality of the quantum world. So what we're doing really is adopting a kind of vague but aspirational quantum realism, and that draws us into the same conceptual space, I suggest, as theology. Well, in case you don't believe me about what I'm suggesting here, let me point out that the religious uptake of quantum mechanics has been remarkable. Quantum fundamentalism has been an absolute gift to religious and spiritual commentators, as well as lifestyle gurus, who also adopt a kind of vague but aspirational quantum realism. Christian theologians, for instance, have found that quantum mechanics is a fantastically rich source of metaphor for models of God's activity in the world, or the God-world relationship, or the mysteries of Christ as fully human and fully divine, and even for the mysterious nature of God's Trinitarian being. And there are particular features of quantum mechanics, wave-particle duality, entanglement, indeterminacy. They tend to crop up repeatedly in these metaphors. Not only do those features of quantum mechanics offer really useful analogies for divine enigmas, but they also overturn rigidly mechanical pictures of the universe that stem from classical physics. So one way of looking at this is to say that if the scientific revolution appeared to close the door on God's active presence in the world by imposing strict laws on nature everywhere, well, the quantum revolution appears to have opened the door again. Well, not only Christian theologians, but many other religious thinkers have borrowed enthusiastically from quantum mechanics to support ancient mystical worldviews, especially from Hinduism, Buddhism, and Taoism. Well, this is a very broad area, but it does tend to result in a kind of synthesized quantum mysticism, which downplays the material world in favor of mind, consciousness, and the deep unity of all things. And you're probably aware that quantum mysticism has been popular in New Age spirituality for decades, and it's percolated far and wide into health and lifestyle consultancy, coaching, and alternative medicine. Let me illustrate with two quantum lifestyle books, which aren't ostensibly about religion, but it's clear that when you read them, they do both take thoroughly mystical angles. And these are bestsellers, so you'll easily find them on Amazon. First, Deepak Chopra's book, Quantum Healing. This has been remarkably successful. It's been in print for 35 years. It's important to know that Chopra is a medical doctor who specializes in oncology. And in the book, he describes how many of his patients experience miraculous remissions of their cancer symptoms by practicing the spiritual techniques that he prescribes, which are inspired by his interest in Hinduism. The point is that the mind can influence our body, even our genes, and quantum mechanics confirms this for us, Chopra argues. The physics teaches about an invisible quantum domain, the most fundamental dimension of reality, from which mind and body emerge and unite. Every cell in our body is conscious, since on the quantum level we are fully embedded in one mind, a cosmic intelligence that creates, governs, and controls reality. And Chopra describes how, when his patients learn this truth, they make a quantum leap to a new level of consciousness, and their symptoms invariably improve. Well, the book on the right, that's a much more recent one from 2021, still a bestseller though, Larry Farwell's The Science of Creating Miracles, makes really quite similar moves, but it doesn't focus on healing or cancer so much as your entire life. So if you're unhappy in your job or your relationship, quantum mechanics can help you, he promises. And he believes that consciousness is fundamental because quantum mechanics is fundamental, and that through your consciousness, you can alter the outcome of quantum events because they are observer dependent. By meditating, you can alter what quantum mechanics is doing, he suggests. So you can control your future and ensure the best outcome. Now, there's less explicit religion in this book than in Chopra's, but he is still influenced by varieties of Hindu and Buddhist idealism, where consciousness is primary and the physical is secondary. Now, those are just two examples of well-known authors in the genre. You only have to spend a few seconds Googling to find many, many, many more. But the backlash from professional scientists has been uncompromising. Pseudoscience is one of the more polite accusations levelled at quantum mysticism. Here are some more. I don't even know what these words mean, actually. I assume they're bad. Quantum flapdoodle, quantum height, I understand that. Quantum woo, or perhaps the most widespread insult of all, quantum quackery. The charge being made here is that the proposals of mystical thinkers like Chopra and Farwell are scientifically illiterate at best. They show no great understanding of the quantum science, and they're potentially harmful at worst, undermining mainstream medicine by peddling untested fixes to vulnerable people. Well, these criticisms are important, I feel. Like many other scientists, I object strongly to the misrepresentation of science, especially if it's for material gain. But I don't think these self-help manuals can be dismissed too easily, or at least not their religious and spiritual aspirations. Like I said earlier, quantum fundamentalism moves in the same conceptual space as theology, and the ordinary non-physicist realises this. She may well find the technicalities of quantum mechanics impenetrable, including all of the questions about its conceptual interpretation, but she knows full well that quantum physics is deeply strange when we try to apprehend it on a human level. So she can hardly be blamed when she concludes that the science confirms ancient wisdom about the mystery at the heart of reality, that consciousness and mind are not secondary byproducts of the physical. And of course, she only has to look at some of the other great figures of 20th century quantum physics like Bohr, Heisenberg and Schrödinger to see them make similar mystical connections in their own popular level books. Quite simply, quantum fundamentalism exerts a powerful pull on the modern religious imagination. And another way of saying this is that ordinary human beings, by which I mean the vast majority who aren't physicists or philosophers, they need the mediation of religious and spiritual interpretations in order to apprehend quantum fundamentalism. Let me put that in terms of two thesis statements. So this is the central argument of my lecture, if you like. First, ordinary human beings invariably grasp for religious or spiritual or mystical mediation when they want to make sense of quantum fundamentalism. Second, quantum fundamentalism needs responsible, that is, respecting the science, religious and spiritual enrichment in order to liberate human beings. But don't take my word for it. Here is what Schrödinger says on the matter. This is a very long passage over 2 slides, but it's so good that I think it's worth showing you. The scientific picture of the real world around me is very deficient. It gives a lot of factual information, puts all our experience in a magnificently consistent order, but it's ghastly silent about all and sundry that's really near to our heart, that really matters to us. It cannot tell us a word about red and blue, bitter and sweet, physical pain and physical delight. It knows nothing of beautiful and ugly, good or bad, God and eternity. Science sometimes pretends to answer questions in these domains, but the answers are very often so silly that we're not inclined to take them seriously. And here's the important part coming up. And the reason for this disconcerting situation is just this, that for the purpose of constructing the picture of the external world, we have used the greatly simplifying device of cutting our own personality out, removing it. Hence it's gone. It has evaporated. It is ostensibly not needed. And he goes on to say, this is the reason why the scientific worldview contains of itself no ethical values, no aesthetical values, not a word about our own ultimate scope or destination, and no God, if you please. When came I? Whither go I? Science is very usually branded as being atheistic. After what we've said, this is not astonishing. If its world picture does not even contain blue, yellow, bitter, sweet, beauty, delight, and sorrow, if personality is cut out of it by agreement, how should it contain the most sublime idea that presents itself to human mind? Well, taking Schrödinger's lament about the scientific method to heart, I suggest that quantum fundamentalism needs to be liberated theologically. We need a supplementary method to that of science, one that can recognize blue, yellow, bitter, sweet, not to mention the most sublime idea that presents itself to the human mind. So I say that we need a method that celebrates our joys and sorrows, one that liberates the subject to contemplate the object with wonder. Well, theology is clearly in view here, but that should come as no surprise if you agree with me that quantum fundamentalism took us into that conceptual space to begin with. So, to determine what quantum fundamentalism means for human beings, for scientists and non-scientists, I suggest we need to supplement the scientific method with a further methodology that's equipped to take religious, ethical, and aesthetic convictions about reality seriously, all the while treating the science responsibly. Any claim about what is most fundamental to our existence should automatically have religious and ethical implications, because questions concerning human flourishing, our values and purposes, automatically come into focus. Questions that can't be answered empirically, even if they first arise from the physics. Is there a methodology that can handle all these weighty demands? Happily, there is just such a methodology at hand. It's called science and religion. As I draw to a close then, let me flag up where I want to go from here, using the theological and philosophical tools of the science and religion enterprise to supplement the science. Well, there are many avenues that our group in Oxford plans to take to investigate the human and theological dimensions of quantum fundamentalism. I've already begun here to look at some of the quantum conceptual interpretations, and others in the group are looking at these in much more detail in ethical, theological, existential terms, particularly the many worlds interpretation. This is Emily and Sean's special focus. But we also, as a group, want to bring a fresh pair of eyes to other implicitly theological issues in modern science, such as the status of quantum physics as laws of nature. For instance, there's a venerable tradition going back at least as far as Newton that says the laws of nature are expressions of God's will as creator of all. They are what God wanted to create. So the basic question for quantum fundamentalism is this: what on earth was God thinking? That's actually a serious theological question that hasn't been addressed. And I hope that we can provide some serious constructive answers. And in the fullness of time, we are ambitious to get other humanities perspectives involved, art, film, literature, for instance, to help us investigate what quantum fundamentalism means for human flourishing. But that is quite a long way off. Well, hopefully I've done enough to convince you that there is a viable research program here, and that this may just have some useful things to say to working scientists as well as the rest of us who might just possibly also be human beings. So, Pro-Vice-Chancellor, Mrs. Idreos, friends and colleagues, many thanks for your attention.